All right, we are going to investigate what is the area under the curve y equals x cubed from 0 to 1, okay? Now, we understand how to do areas. Doing areas is not a problem. You've been doing areas for a long time. You can find areas of rectangles, you can find areas of squares, trapezoids, parallelograms, circles, right? But to find the area under a curve that does not meet any of those criteria, what we oftentimes opt to do is to do it with rectangular approximation. So 1 cubed we know is 1. So what I'm going to do is I'm going to break this up into 4 regions. I'll start here with region and 4 regions. This is going to be 0.25, this is 0.5, and this is 0.75. Make it a little bit bigger so we can see it. So there is the 0.1 comma 1. Then this comes straight down here to 1. So here we have 0.5, 0.25, and 0.75. I'm going to first start here with a rectangle that has no area. Then I'll come up here and a rectangle that has that area. I'll come up here, a rectangle that has that. Then I'll come up there. And I'm going to call this area A sub L because it's the lower approximation for the area. You should agree with me if I add up those 3, because that one has no area. If I add up all 4 rectangles there, I will get an approximate area, crude and rough, but it's an approximate area then. So I need these heights. We know that height is 0. This height right here, I'm going to get when I put 0.25 in, when I put 0.5 into the equation, and when I put 0.75 into the equation, I will get all those heights. I have those calculated for you right now. So my heights here, this one is 0.0156. This one, the second one is 0.125. The next one is 0.4219. Okay? If you take length times width, length 0.25 times 0 is 0. That one's gone. Okay, there's no area in that first rectangle. The length times width of this one right here, okay? Here's the little width coming up. The length, I've got to take this times 0.25. Here's the length coming up here on this one, okay, 0.125. I've got to take it times 0.25 to get the area. And for the last one, I have to take that one times 0.25 to get the area. If you do all the math and add all those up, you will get, I've done this ahead of time, is 0.1406. Now, there's another way you could have done this problem. Instead of doing the A sub L, which is 0.1406, you could have done A sub U, which is the upper approximation. Start over here and come over here and come the whole way down. This whole big rectangle, start here and come down. Start here and come down. Start here and come down. Just as A sub L was an approximate of the area under this curve, 0.1406, but because there is so much space we didn't measure here, this would be lower than the true area. A sub U will be measuring these 4 big rectangles, and look at all the waste here. A sub U is going to give us a measure of area that is too big, okay? But what exactly is that? Well, once again, 0.25 here has the height of this particular rectangle. And when we took 0.25 initially to get this rectangle, that's going to be the height of that one. So this would be the same figures. So it's going to be 0.0156 plus 0.125 plus 0.4219. All of these lengths here, here, and here. And then the last rectangle length is there, which is 1. Those each have to be multiplied by the width of the rectangle, 0.25, to get your total area. And I did that ahead of time. I got 0.391. What is rather interesting, if you average those two, we know the true area is somewhere in the middle of those two. If you average those two, it comes out to be roughly 0.26, which is actually very, very close to the true area. The true area is 0.25, which you will learn a little bit later in calculus when you do integration. Okay?